Okay, let's start, guys. And then this is tutorial 2 question 4, which you have requested me to record for you. So the time taken for the cheetah to reach the ground. So basically we are given that the cheetah was walking at a initial velocity of 1.5 meters per second, and when it saw the gazelle, that's when it started to accelerate, which means to run towards the gazelle. And then the change in x, which means the distance where the gazelle from the cheetah, from the time when it started to run, that's where the distance between it's 43 meters. So that is our change in x. And remember, this is a motion in a straight line. So what do you know? The final velocity, we don't know. The time, that is what we are required to find. For how long will it take the cheetah to reach the gazelle? Okay. So I just put this sketch just to summarize what is happening. Here. So this is the velocity, and then this is our time. So we are given the acceleration, so it's always the slope, but the initial velocity is not 0. That's why I did not draw it from here. If it was 0, I would start the line from here going upwards. But since the velocity is starting at 1.5, so I had to put here the initial 1.5, and then I just put a straight line because it's accelerating. Okay, it's accelerating, so the acceleration will be just the same. So until it reaches this point, something is going to happen. It will be a different thing when it stops. Then the velocity, it already goes down to naught after say a certain time. So the graph will just go down to naught once it reaches the gazelle. Okay, and we know our acceleration is the slope, which is the change in y over the change in x. Okay, so we are going to use two equations of motion here. The first one is Vf is equals to Vi plus At. The second one is Vf squared is equals to Vi squared plus 2A change in x. So these are the two equations which we are going to use. So solving for the first one, we just substitute the value of V initial, which is 1.5. And then the second one, the acceleration we are given is 9.25 times t. Okay, so basically this is how we'll be operating this problem. So we have our Vf, which is 1.25, which is Vi squared. Okay, 2 multiplied by the acceleration by change in what? Change in x. So this is acceleration, change in x. So by substituting, you find out V squared is equals to 797.75. Okay. So you can round it off, but you can work with it like this, okay, as it is, because that's the actual. Substitute equation 3 into 4, or you can substitute equation 4 into 3. But what is very easy is for us to first find the square root of Vf, which is square root of Vf squared is Vf, and square root of this. So Vf squared from equation 4 is equals to 797.75. So once you square root both sides, we are going to get this, okay, which is square root of 797.75. Then we can make it equation 5. So from there we say, since we have our equation 3, then this is our equation 5, which we just calculated. So we substitute 5 into 3, equation 3. Then what do we get? You just where there's Vf, you put that 1.5. So we are substituting here plus 9.25t. Therefore, square root of 797.75. You push 1.5 to the left hand side since you want to group the like terms together, numbers and variables on their own. So negative 1,5 on the left hand side, we push it, it becomes negative. Then on the right hand side, we still have 9,25. Okay, what do we do next? So now we are going to do division. We are going to divide both sides by 9,25. So you divide by 9,25 this side, we are left with t. You divide by 9,25 the whole of the left hand side. Okay, so t is equal to this. Okay, t is equal to that. You simplify, you get 2,89 seconds, 891 seconds, just round off. So now, once we have found t, we can solve for VF. How? By just substituting the value of t into this. So VF is equal to 1,5 plus AT. Okay, so basically that's what we'll be doing, and then we will find the value of t. So the value of t, you find the value of t to be VF is equals to, solve the right hand side, 28,24 meters per second. It's towards the gazelle, that is the velocity. Or if you had assumed that the positive is the right, then you can say my final velocity is 28,24 meters per second to the right. So that is it. So, but if they ask you the magnitude, you just leave it there as the number only. Magnitude, you just leave it as the number only.